Many of my loyal viewers may remember back around 2016, I created a project called the WeatherSense 9000, a weather station for my home. It consisted of this main unit, the receiver in the middle, and then a remote for another room, and then these Arduino sensors, and they would send the temperature and humidity back to the main unit. I loaded a custom bootloader on these three modules so I could get low energy sleep mode for better battery life. The main receiver unit was based off what they call an iBoard, which had an Arduino Mega as its chip, and I used a Nextion display. And it shows the temperature and humidity of the three sensors rotating every 10 seconds. If I tap on the center of the screen, it'll show a graph of the barometric pressure over time. And the problem was it was resistive touch, so it didn't work so well. If I push this little gear down here, it would allow me to change the daytime and nighttime brightness of the display. Now the main receiver unit would update the remote unit in another room over Ethernet, and that stopped working when I changed my network infrastructure recently, and I can no longer get the web server client working on the LAN. And also, since I wanted access to this information outside of the house, I had to open ports on my router, which was a security issue, so I wanted to do away with this whole concept. There was a lot of custom design with the electronics. I had to 3D print these enclosures, so I wanted to move on to a newer concept. So I started doing some research, and I immediately stumbled upon these SensorPush wireless sensors and their ecosystem, and it's a really nice setup. The base setup is one or more sensors which talk Bluetooth back to your phone, and they have a beautiful app with nice graphs and history. But then I found out they have this gateway, which will allow you to push all your readings into the cloud, and even better, there's an API, so you can gain access to that information. They had a lot of good reviews, and although not cheap, I decided to take the plunge. I bought 3 sensors and the gateway. And they even have a modern web browser dashboard for your sensors that show historical data graphs. So all this was great. I had this information on my phone, I had access from outside the house, and I could get it on any web browser. But the joy was somewhat short-lived, because I kept looking over at that empty spot where my old WeatherSense 9000 had been for all those years, giving me immediate readings of what the temperature and humidity was outside and in my house. I had a concept in mind, and I started reading all the documentation on the SensorPush APIs online, trying to figure out how I would incorporate this online information and pull it down into some type of unit that I could build for my house. Now, as mentioned, my previous build was based off an iBoard in an enclosure that I 3D printed, hooked up to a Nextion display. And that was based on Arduino Mega on that red iBoard there. So I wanted to try something different. I had never dealt with an ESP32 before, and they do make them with built-in displays, so I went searching. And it didn't take long. A company I've dealt with before, Elecrow overseas, had the CrowPanel 7-inch available. It's a capacitive touch 7-inch display with an ESP32 microcontroller built in. And they have these acrylic enclosures you can purchase. So look at the price here. It's $27, and the acrylic enclosure is like an extra $4 or $5. And it's a beautiful enclosure. Really protects it. And boy, did things get complicated real fast. I ended up putting in way more effort and time than I thought on this project, an estimated 100+ hours. I'll spare you the gory details for later in this video, but for now, I'll show you what I came up with. And now introducing the WeatherSense 9001. And this is what I came up with. My project and a CrowPanel 7-inch display with an ESP32 microcontroller inside their acrylic case with a 3D printed stand that I created. So here's an overview of the unit. We'll show the readings for the porch sensor, the garage sensor, and the basement sensor. For each sensor, we show temperature, humidity, battery voltage, last time and date of update, and the Wi-Fi signal. At the bottom, there are some status indicators. And if I tap on the screen, it'll show the barometric pressure readings over time for the last 18 hours, reported every 30 minutes. Most of the fields will turn red if any of the threshold limits have been exceeded. This is really good for something like a low battery indicator or a high or low temperature or humidity reading. And what's really neat is I was able to read these thresholds from the SensorPush app. So whatever I set over here will be pulled in through the API into my programming and used on my display. So it's just set at one place. As I mentioned, I purchased the $4 acrylic case, which protects it and exposes all the connectors on the board, which would be nice if you wanted to hook up additional sensors, for example, an indoor temperature and humidity sensor. But the acrylic case also provides these nice threaded inserts here for wall mounting or some other type of stand or attachment. So in order to get the dimensions and the spacing correct for the screw holes, I had to fashion up a 3D model of the case itself. This allowed me to create some legs that I could then 3D print and use as a stand. And after a few iterations, the 3D printed legs came out really nice. They provide a very stable platform. Now let's review some project challenges I had along the way. First, I had to learn the Arduino IDE and specific ESP32 board configurations for a successful compilation. I had to learn the LVGL graphics library and specific code settings, or I'd get a blank screen or a crash. There are very thin margins for setting the stack size in the Arduino IDE for my program. If not, it would crash, and this requirement changes every time you change code or the libraries. I had to learn Squareline Studio to create the on-screen graphics and learn how to integrate that into the ESP32 Arduino code. I had to learn the SensorPush API calls, and there's at least 4 in my project. I had to learn the Arduino JSON library, which allows you to get the JSON data back from the API calls to SensorPush. And I had to integrate the old reliable Arduino time zone library to convert UTC time to the local time. I had to learn how to use Wi-Fi on the ESP32 and on my new IoT network. And remember, I haven't done Arduino IDE or C++ programming in over 8 years. Oh, and the initial setback when I attempted to use Platform I/O on Visual Studio, and then had to abandon it because it was such a disaster and came back to Arduino IDE, which was good because there's more resources and help topics. And there were coding issues with pointers, character arrays versus strings in C++, data arrays for sensor readings, timers, all to account for the API authentication limits. So yeah, it's been a challenging couple of weeks. Oh, and I almost forgot, my integration with ThinkSpeak, an IoT platform in the cloud. I write all my readings up to the cloud. So I've been doing this for over 5 years, and it shows me all the history of the temperature and humidity readings, the pressure, and my battery for my 3 sensors over time. And you can change settings on each of the graphs, for example, to show a different time range. I really like the way the project turned out. It's been very useful, and I've learned a lot along the way. It's worked pretty flawlessly for the last month or so, only crashing once or twice when the network went away. I have to look into that. Now, I've spent a lot of time and effort on this, and I'm still debating before sharing code and everything publicly. So I may share the code later with a donation request or something similar. But there will likely be a detailed video in the future. So I hope this has been useful to you, at least entertaining, and maybe inspirational for you to work on your own project. In any case, as always, I thank you for watching.